Today we're going to be spending some time taking a look at the periodic table. And what I'd like you to do is, if you can have this as a printout, because we're going to be referring to this a little bit in this video. It's just good to have that printout as a reference. So here we go. The periodic table is called the periodic table because it is organized in a very, very particular fashion. We have these columns that go up and down like this, and these are called your families, or sometimes they're also called your groups. We're going to call them groups in this class. But they also have these rows that are going across. And these rows that are going across like this, these are called your periods. So I'd like you to know the names of and the difference between each of them and to distinguish between a period and a group. So the first thing we're going to take a look at is what's called the periods. Again, this is called the periodic table. So much like you go through your periods in the day, you have period 1, you have period 2, period 3, you go through period 7, etc. And then the following day, it's usually the same, period 1, period 2, period 3. So we have these repeating patterns over and over and over again. And again, we see that on the periodic table when we go across, because we're going to be seeing these patterns that occur within these groups. And we'll take a look at that in a little bit. So periods go across a periodic table. Okay, so for example, take a look at your periodic table. The first period is going to be period 1, and it goes from hydrogen and it goes across to helium. So that's going to be period 1. Period 1 goes from hydrogen all the way across to helium. Period 2 has a little bit more. Period 2, which is right here going across, goes from lithium and then all the way across to neon. So period 2 starts off at lithium, goes across to neon. Excuse me. Period 3, if we look at the next period going down, period 3 starts with sodium and goes all the way across, and it ends at argon. So the symbol for sodium is going to be Na, and it goes all the way to argon. What's interesting is we talked about the electron shells. If you remember the 2-8-8 rule, we'll take a look how many elements are in period 1. We have 1, 2. Count how many are in period 2. You should have counted 8. How many are in period 3? You should have counted 8. This follows the 2-8-8 rule. So that's something to note, and we'll discuss that later as well. So the periods go across. Okay, so they go across the periodic table like this. We also have these other columns, and these are called your groups. Now, sometimes they're called families, but we will call them groups, but you might see in some of your handouts, your activities will be the families. So the families are in columns. They're in columns, and these columns that go down. So they go down the periodic table. Okay, so for example, right here, hydrogen is group 1, and it goes down like this. The next group is going to be your group 2, and it goes down this way. But then we have this giant block. You'll see this giant block in the middle right here. These are called your transition metals. They sort of zigzag down, but we're just going to call this giant rectangular block for now. And again, these are called your transition metals. And then after that, we skip the transition metals and we go to group 3, then 4, 5, 6, then 7, then group 8. So we're just going to do a brief drawing on that. We have group 1. Group 1 goes down. Then we have next to it group 2, and then group 2 goes down. And then we have this giant rectangular block. And again, these are called your transition metals. Then we have group 3, 4, 5, 6, 7, and then 8. And again, your groups go down like this. So the significance of your groups, and this is the order of the periodic table, there's two main things to take from this. And that each group has the same number of outer electrons. Each group, so all the elements in that group have the same number of outer electrons. So each group has elements with the same number of outer electrons. We're going to abbreviate electron as E minus. And again, these outer electrons, these are called, have a special name, and they're called valence electrons. Let me give you an example. Here's hydrogen. Hydrogen has one proton, it has one electron. So therefore, it is a group 1. Helium has 2 electrons. It sort of violates it because it doesn't have the 8, but we'll see that in the next one. But this has 2 electrons. That completes the first shell. So that means the 2 electrons fit in that first shell. We now have to go to the second shell. Let's take a look at lithium. Lithium is element number 3, which means it has 3 protons and it has 3 electrons. So how many fit in the first shell? 2. How many are left over in the second shell? If 2 of the 3 fit in the first, that means I have 1 in the second shell, just like my hydrogen has 1. All of these are going to have 1 in their outer shell, or they're going to have what's called one valence electron. We'll see that in our lab activity as well. Also, another point of significance is that the periodic table is organized by the valence electrons, just like we showed here. This has 1 valence electron. This has 1 as well. Let's take a look at this really quick. This has 11 protons. It has 11 electrons. How many fit in the first? 2. How many fit in the second? 8. 2 plus 8 is 10. How many of my 11 are left over in the third? 1, which is why it is a group 1. So the periodic table is organized by the valence electrons. So the periodic table is organized by the valence electrons. And we'll have a handout on that after this lecture. So what we're going to do is we're going to take a look at the groups 1 through 8, and they all have a particular name, and they all have interesting characteristics. So this is going to be item number 3, and these are going to be our group names. Group 1 is called Group 1, but it also has a special name, and that name is called alkali metals. So Group 1 is your alkali metals. Some characteristics of alkali metals is these are not like your copper or your silver or your gold. Those are very, very hard metals. These metals are very soft. You'll see this in the video coming up very soon. They're soft. They're also very shiny. And they're also very reactive. Okay, so the alkali metals are going to be lithium, sodium, and potassium. And again, this is going down the chart. So if we take a look at this, we have lithium, sodium, and potassium. Hydrogen is not a metal. Hydrogen is a gas. So it is a group 1, but it is not an alkali metal. So your alkali metals actually start with lithium and go down the chart like this. What's interesting is that as you go down the chart, you increase in the reactivity. So you increase in the reactivity when you go down the periodic table in that group. So what I'd like you to do now is I'd like you to watch the video for group number 1, which is the alkali metals. And you go ahead and pause, and I'm going to continue on after just a few seconds. Okay, hopefully you watched that video on the alkali metals. We're going now to the next group. This is group 2. And group 2 are called, very similar name. Group 2 is called your alkaline, not alkali, but alkaline. So I'm going to underline that. Alkaline, and they are called earth metals. Okay, let's take a look at our group 2. Our group 2 consists of beryllium, magnesium, and calcium, and then going down. So we have my beryllium, magnesium, and calcium. And again, that continues going down. These are harder metals. Remember how your alkali earth metals were very, very soft? These are harder metals. Okay, calcium is a very hard metal. Magnesium is a hard metal as well. And what's interesting is that these are not as reactive as group 1. Not as reactive as group 1. In chemistry, we discover why this is so, and it has to do with their valence electrons. So now we're going to be taking a look at the next group going over. We have group 1, we have group 2, and again we have all these transition metals. It's a giant, giant block, okay? So I don't want you to know all of them. I do want you to know a few of them. I just want you to know that the transition metals are located in between groups 2 and 3. So if you take a look at it where they are, here's group 2 and here's group 3. Most of them are wedged within group 2 and group 3. So it's this rectangular block. It's a rectangular block of elements between groups 2 and 3. Okay, so some of the characteristics of these guys is they're all going to be very shiny, and they're all hard metals. So they're shiny and they're hard metals. Some very typical ones you might be able to recognize are going to be Ag for silver, Cu for copper, Ni for nickel, Fe for iron, zinc, Zn, Au for gold. Okay? These are all going to be your very, very hard metals. So we have some examples are going to be Ag, which is going to be your silver, your Zn for zinc, and your Ni for nickel. There are many others like copper and gold as well. Okay, so at this time, I would like you to watch the video on group 2 elements, and pause now, and we'll come back in a few minutes. Okay, hopefully you watched that video, and now we're going to take a look at the group 3. Group 3 is named after the top element, which is B, and that represents boron. Group 3, 4, 5, and 6 are all named after their top element. So group 3, this is called the boron group. Okay, and boron is used in making our glassware in this classroom. So boron is being used for our glassware. It's called borosilicate glass. Okay, boro, and the silicate is referring to the silicon that's also in there as well. But in that boron group, we also have aluminum, Al for aluminum. And we have Ga for gallium. And there's an interesting video that I have for you on group 3, and it particularly looks at gallium. So please go ahead right now and take a look at the video for group 3. And if you can pause now and come back after you've finished. The next group is going to be the carbon group. If you remember, the elements or the groups 3, 4, 5, and 6 are all named after the top ones. So the top of group 4 is going to be our carbon, or our carbon group. Okay. Carbon is actually a nonmetal, and it's found in just some typical characteristics. Carbon is what we eat. We eat foods with loads of carbon, and we have that in sugar, for example. We eat proteins, which is loaded with carbon, and fats are also loaded with carbon. So one of the characteristics of carbon is we find this in living creatures. It's what eats, it's what sustains us, it's what provides us energy, actually, by eating these carbon-based living creatures. If you go underneath carbon, you will see another one, and this is going to be silicon. We talked about silicon when we just looked at borosilicate glass. But silicon, so carbon is going to be your C. Boron is going to be capital B. Silicon is going to be Si. And again, if you take silicon and you add oxygen to it, then you get glass. So when you add O2 to silicon, you get silicon dioxide, and then you get SiO2, and this is equal to glass. It's also what makes up of the majority of the crust, the outer crust. The Earth's crust, sand, quartz, rock, is all made up of silicon dioxide. So it's glass, it is sand, and it's what is rock. It's what rock is made out of. Another familiar one that you'll find in this is going to be tin. And tin has a strange symbol, and it's SN. So we have tin. And another one, if going down, you'll see, and it's going to be PB, which is going to be lead. Okay, and lead is not found in your pencil lead. It's actually going to be graphite, which is carbon, which is in the same group. And And lead, it has the symbol of Pb. It's based on a Latin word, which means plum. And so they use the first letter of plum and the last letter of plum, and they create this word, the symbol called Pb, because pipes were initially made out of lead, and if you need someone to come fix your pipes, you have to call the plumber. That's why that has that symbol. On to group number 5. Group number 5 is going to be the nitrogen group. So group 5, which is the nitrogen group, capital N. It's good to know these symbols. And nitrogen is found in the air as N2. It's also found in fertilizers. Right now, people are buying a lot of fertilizer to water their lawn. That's because it contains nitrogen. That nitrogen is what makes the pigment in grass green, which is chlorophyll. Chlorophyll needs to have nitrogen in order to be greenish in color. Also in this group, we'll find phosphorus underneath of it. So we have P, which is phosphorus. And you find phosphorus in matches. I think if you remember this from the Hunting the Elements video. And you also find it in flares. Okay, I actually have 2 videos for this. So if you can take some time now and watch the 2 videos, very interesting with the discovery of phosphorus, which is one of those videos is about. So please pause this and go and watch that video, and then you guys can then come back. Hopefully you watched those videos and enjoyed them and have that reference and that context. We're now going to be looking at group 6. Going over to group 6 is going to be my oxygen group. Oxygen is going to be a capital O. And of course, we find oxygen in air. And in the video on Hunting the Elements, it was taking a look at oxygen. Oxygen makes things very reactive. If you think of trying to burn a candle needs the oxygen in order to burn. It needs for lots of other reactions as well. So it's very reactive with everything. Very reactive. Also in your group 6, beneath that you'll find sulfur. So we have element S, and that's going to be your sulfur. This is interesting. Sulfur is yellowish in color, and it's the most abundant element in the crust. 48% of the Earth's crust is sulfur. The other portion is going to be silicon and oxygen. Next group is going to be group 7. Group 7 does not have the name after the F, which is the fluorine. These have a very special name, and the name for group 7 is called halogens. The reason why they're called halogens is it's named after the Greek word, which is halo, and halo means salt. So halogens are called the salty ones. The reason why they're called the salty ones is because within this group we have chlorine, and inside of salt we have sodium chloride, which is why this is called the salty ones. So halogens are called the salty ones, and they include fluorine, and going down you have chlorine, and then you have bromine going down your group like this. Now, what's interesting is that group number 1 is the most reactive of the metals. So let's go back to this group name, alkali metals. It's the very reactive, and again, these are your metals. However, your halogens, fluorine, chlorine, bromine, these are your nonmetals. So these are the most reactive. The significant thing about this is that they're most reactive of nonmetals. So on this side of the periodic table, we have your metals. On the right-hand side, we have the nonmetals. It's interesting because that's how we name them as well. We name the metal first, sodium. We name the nonmetal next, chlorine or chloride, sodium chloride. So the most reactive of the nonmetals. And what's interesting is you're going to see a video, they get more reactive as you go up. So as you go up this group, the activity increases. The activity increases as you go up the group, not down as you would with the metals. I have 2 videos that I'd like you to watch. So if you can please watch those videos right now on Group 7. And lastly, we're at the end of our groups. We are at Group 8. This is not called the helium group, but this is a special group of gases. And these are called the noble gases. If you look at noble gases, they're called noble because they don't react with other things. They don't interact with other things. It's the nobility of the elements on the periodic table. And the reason why is they have full shells. Hydrogen has 1. Helium has 2. That completes the first shell. Okay? Lithium has 1, 2, 3, 4, 5, 6, 7, and then neon has 8 electrons in the second shell. That makes it full. It's a full shell. And when the shell is full, it doesn't react. So noble gases, one of them is going to be He, helium. So helium has 2 outer electrons, or 2 valence electrons. The next noble gas is neon. Neon has 8 valence electrons. If you go down to the next one, we have argon and Ar. Argon also has 8 valence or outer electrons. Noble gases don't react. And the reason why they don't react is because they have completed their shells. They have full outer shells. In chemistry, we talk about how the reason why we have reactions is because we have elements that don't have full outer shells. These guys do have fuller outer shells, so therefore they don't react. They can't react because their shells are already full. Okay, that's it. There also is one more video, so if you can watch the one video to conclude this lecture.